indicator. So amines and amides are both functional groups containing the atom nitrogen. However, amines are NHX molecules connected to a carbon chain through carbon-nitrogen sigma bonds. And it can be bonded to up to 2 alkyl groups by sigma bonds, leaving 2 electrons to form an electron pair. The nitrogen in this compound will have 1 lone pair and 1 to 3 carbon-nitrogen bonds, made up of the bond between the nitrogen and the carbon chain, and then up to 2 alkyl groups. The remaining bonds, so it has 3 valence electrons, so it can make 3 bonds. So remaining bonds can be taken up by the hydrogen atoms, in total forming 4 electron pairs, 1 being the lone pair. These functional groups can be an offshoot of a carbon chain, or can replace one of the carbons in an aromatic hydrocarbon, forming a heterocyclic amine. So that can be seen right here. As you can see, the nitrogen is taking up one of the corners, and each corner is made up of a carbon. So, it's called a heterocyclic because usually each corner is made up of a carbon, and the nitrogen is taking up one of these corners, and therefore it's more than one type of atom forming the ring. Amines are weak bases due to the lone pair of electrons above the nitrogen atom. Nitrogens making up aromatic rings as well as nitrogen atoms bonded to carbonyl groups have planar configurations and are not stereogenic centers. In other molecules, nitrogens are stereogenic pyramidal due to its 3 bonds and a lone pair. Because of the polarity of the NH bonds on the amines, it results in hydrogen bonds, which is a strong form of dipole-dipole interactions, and which is one reason for its relatively high boiling points. As you can see, they're all pretty high. They're all in degrees Celsius. So even though the hydrogen bonds are weaker than the OH bonds found in alcohols, they are a lot stronger than bonds between alkanes or hydrocarbon chains. So therefore it's going to have a lower boiling point than molecules with OH bonds, but it's going to have a higher boiling point than hydrocarbons. The most negatively charged portion of the molecule is the nitrogen because of its lone pair and the electronegative attraction of the nitrogen. Most amines are Lewis bases and are therefore nucleophilic. This is because of the electron pair above the nitrogen, which is more easily removed than the one on an alcohol, making it a stronger base. All amines usually will react with strong acids to produce water-soluble salts. The pOH changes depending on the substituents and the resulting hybridization of the nitrogen, delocalization of the non-bonding electron pair and its aromatic ring, and the rehybridation of the amino-nitrogen atom. Amines are usually bases, but some amines are weak acids with the same 3 factors affecting its acidity. There are various different nomenclatures for amines, terms like primary, which is right here, which is resembled by the 1 and the degree, secondary right here, and tertiary right here. And these are used to refer to the number of alkyl or aryl substituents that are bonded to the nitrogen atom. More simply put, the number of carbons bonded to the nitrogen. So if we look back here, this nitrogen right here is bonded to 2 carbons. The R stands for carbon. So therefore this would be a secondary amine. Right here, this one is bonded to 2 hydrogen, or 1 carbon. So it's going to be a primary amine. The geometrical shape of its functional group is a trigonal pyramid with roughly 107 degrees between its bonds. Now moving on to amides. Amides are molecules that contain nitrogen atoms bonded to a carbon of a carbonyl group. All amides have a suffix of amide. When a carboxyl acid and amines or ammonia react, this process is known as amidation, and it forms an amide. This reaction is usually very slow, so in living things this process is usually made faster by an enzyme. A polyamide, like protein, is a long chain of amides bonded together. There are different types of amides. A simple amide right here, when the nitrogen is bonded to 1 carbonyl group, so nitrogen bonds one carbonyl group, and up to two hydrogen atoms, and two hydrogen atoms right here, or a substitute amide right here, where the nitrogen is bonded to a carbonyl group and one or two alkyl or aryl groups right here. And the remaining bonds are taken up by the hydrogens so that the nitrogen forms 3 sigma bonds. As you can see here, so one is bonded to the carbonyl group right here, one is bonded to a carbon chain right here, and one is bonded to a hydrogen right here. So the bond between nitrogen and carbonyl group is called an amide linkage, and is quite stable. Most simple amides, except for formaldehyde, are solids at room temperature and are usually water soluble. So again, this is because of their NH bonds, which have a relatively high dipole-dipole interaction with other molecules, creating really strong intermolecular forces. Therefore, the melting and boiling points range depending on what the molecule the amide is bonded to, but they are considered to be relatively high. These characteristics originate from the amide's polarity and the hydrogen bonding of the NH bonds. The breaking apart of amides using an H2O molecule hydrolysis is used to separate an amide from a molecule, producing a carboxylic acid and the salt of an amine or ammonia. This process is usually slow in distilled water, and either the addition of acids and bases or catalysts to the water helps speed up the reaction. So I compared this to the finishing a puzzle. So amines and amides are compared to the last piece of a puzzle. The puzzle is not complete until the last piece of or functional group completes a picture or the molecule. Before this, the picture was incomplete and it was therefore not functioning as the end product is supposed to. By adding the piece, it adds to the picture to make it complete and function as the end product is supposed to. This is similar to the functional group binding to the molecule since it affects the pH, the boiling point, the molar mass, as well as many other chemical and physical characteristics of the molecule. So as you can see here, the picture isn't complete until the last piece of the puzzle is added. And right here, this is a reaction where an amine is added onto a molecule. So this new molecule is going to have a new pH, new molar mass. It's going to have a lot of different chemical and physical function characteristics, and the original are OH2. So now functions. DNA, deoxyribonucleic acid, and RNA, ribonucleic acid, are both made up of monomers known as nucleic acids. So that's resembled right here. This is DNA and its subparts. So each nucleic acid contains a 5-carbon sugar right here, a phosphate group right here, and a nitrogenous base right here. Each nitrogenous base contains a single or double ring structure containing nitrogen, carbon, oxygen, and hydrogen. The double ring structures are here, and here are the single ring structures that make up the nitrogenous bases. So these ring structures are heterocyclic amines, which give nucleic acids their specific characteristics. Medicine. So here we have the heterocyclic amines, right? We have the NH and the N making up 2 corners of the cyclic molecule. And the amines, as you can see here, the NH and the N are connected because of intermolecular forces, and so these are the H bonds, and this is because of the amines that they are being connected, which is very important to the DNA structure. On the other hand, medicine, like alkaloids and vitamins containing heterocyclic amines, which behave like bases, and they can react with hydronium to form ammonium salts. This process is used to extract alkaloids from plants. Plants produce these substances as a defense against any predators, while humans have extracted these from plants to use medicinally. So that's right here. Poppies are one form of plant that produces molecules we use for medicine. I'm pretty sure poppies are used for the production of heroin. So on the other hand, proteins right here are a type of macromolecule composed of monomers called amino acids. Proteins have many functions in living things. For example, one type of protein are enzymes which catalyze chemical reactions. Proteins' individual functions depend on the amino acids that make up the polypeptide chain and the way they are organized through intermolecular bonding. All amino acids are made up of an amine functional group, a carboxylic acid functional group, and a hydrogen in a side chain which differs based on the amino acid. So here's the amino group, the carboxylic acid, the hydrogen, and the carbon chain. So proteins have many different functions, and they're dependent on the structuring or the arrangement of the R chain right here. When two amino acids bond to form a peptide bond, amidation occurs. The amine functional group will bind to the carboxylic acid of another amino acid, forming an amide and a water molecule as a byproduct. So as you can see here, this is the reaction. The carboxylic acid is going to bind to the amine, and this H and this OH is going to come off, forming an H2O molecule. Kevlar is another function. Kevlar is a synthetic polymer that has a high tensile strength to weight ratio and is made up of 1,4-phenylene diamine and tetraphenyl chloride. The molecules making up this material are connected by amidation. The carbonyl group of one binds to the amine group of another, forming an amide which connects to them. The partial negative charge of the oxygen of the carbonyl group and the partial positive charge of the hydrogen of the amine group of two different molecules adds to the Kevlar's high tensile strength, which can be seen here. So the oxygen right here is connected to the hydrogen right here, and that's seen here, which adds to its strength, right? It's intermolecular forces between the molecules. However, the additional strength comes from interaction between unhybridized p orbitals in the six-membered aromatic rings. This is also known as aromatic stacking. Thank you.